Hello dear students, let's solve this question on view serializability. We are given a schedule S with two transactions T1 and T2 and we are asked to check whether this schedule is view serializable. Now what's the method actually? The method is that find out how many serial schedules are possible. Now let's take S1 as one of the serial schedules with T1 and T2 transactions and another schedule S2 with T1 and T2 transactions. What are the possible serial schedules for this? Let T1 run first. So read A, write A, read B, write B. You observe what we are doing is we are allowing T1 here, this T1, check the marker, T1 to start and end first. And then after T1 ends, you can ask T2 to start and T2 will continue till it ends. So this is one of the serial schedules, isn't it? And the other serial schedule possible with the same concurrent schedule S is that let T2 run first. So the operations of T2 execute first, correct? And then operations of T1, as you see, execute till T1 actually ends. Now we have to check whether this schedule S containing these two transactions T1 and T2, is it view equivalent with S1 or view equivalent with S2? If it is view equivalent with any one of the serial schedules, then we say the given concurrent schedule is view serializable. But then this is time taking process, isn't it? How can you check both the serial schedules and then you have to go through those three steps of initial read, final write, and updated write, isn't it? So is there any other method? Yes, definitely. What we have to understand here is that first step is you check whether the given schedule S, whether the schedule S is conflict serializable. Is it conflict serializable? You check. Now you know very well how to check whether the given concurrent schedule is conflict serializable, and you also know how easy it is by constructing precedence graph, isn't it? And let's say that S is conflict serializable. Let's assume we don't know yet. Let's say that S is conflict serializable. Then surely if S is conflict serializable, then S is view serializable. That's great. That means if you want to check whether a schedule is view serializable, you don't have to rigorously start checking for all the serial schedules and all those three conditions of initial read, final write, and updated read. But then first you check whether that schedule is conflict serializable. If it is, then stop. Say that it is view serializable, definitely, isn't it? But what if S is not conflict serializable? If it is not conflict serializable, then you go on to check, is this S, then check, is this schedule S equivalent, basically view equivalent, isn't it? Is it view equivalent to some serial schedule, to some serial? I hope you're understanding. So you will check the serial schedules equivalence only if it is not conflict serializable. So this process, which I was telling, check whether this S is view equivalent with S1 or with S2, can be checked after conflict serializability. So let's check conflict serializability. I assume that you know how to check conflict serializability. We have two transactions T1 and T2. Okay. Let's start with the first operation, read A. It will conflict with write A. It is T1 to T2. Okay, T1 to T2. Fine. Then let's go to this write A, this operation. It is going to conflict with write A here in T1. So it is T2 to T1. Correct? That's it. That's it. There is a cycle in the precedence graph. So what you understand is that the given schedule here is not conflict serializable. Please try to understand. It is not conflict serializable. So if it is not conflict serializable, then you can't just declare that it is not view serializable. If S is not conflict serializable, then you will have to check view equivalence with the serial schedule. So this long process now starts, isn't it? If this S was conflict serializable, we were most lucky and we would stop the process saying, okay, as it is conflict serializable, it has to be view serializable also. I hope you are understanding. So how do you check now whether this is view serializable? First, let us check equivalence of this schedule given with S1. Okay, let's see with S and S1, two schedules, who is doing initial read. I'll write in short, initial read for A in S. Initial read for A in S is done by T1, correct? Now, then initial read on A must be done in S1 by T1 itself. And you can see initial read in S1 is done by T1. Great. What about initial read of data item B? Who is doing initial read of B in S? Initial read of B in S is over here. It is done by T2, you observe. Before this, there is no read. So T2 is reading B. What else? What do you know now? Who is doing initial read in S1? Initial read in for B in S1 is getting done by T1. Now you watch this. Now you watch this. Initial read itself for data item B is not matching. I hope you are understanding. Then you can stop and say that S and S1 are not view equivalent. Fine. They are not view equivalent, definitely, because initial read itself is not matching. If initial read is not getting satisfied, then don't waste your time in checking final write and other conditions. Okay. But then, hello, we have got one more schedule over here, isn't it? There are two serial schedules possible. Who knows? This S might be view equivalent with S2. So let's try again. Okay, it's equivalence. So we have got S and S1. Who is doing initial read? Initial read on data item A in S. We know that it is T1. We checked it last time. And who is doing initial read on A? Listen very carefully. Initial read on A in S1. You can see I'm underlining it. It is done by T1 itself. Okay. What about initial read? Initial read on is doing initial read on B in S. Initial read on B in S is done by T2. We have seen that earlier, or you can confirm it from the schedule given. And who is doing initial read on B in S1? In S1, initial read on B is done by T2. Fine. That means the condition for initial read on both the data items is satisfied. Okay. So now we still expect that this two schedules might be view equivalent. Now we will have to check for final write, isn't it? Let's see final write on both data items in both the schedules, S and S2. Okay. Who is doing final write on A in S? Look at this. Final write on A is over here. After this, there is no write A operation and it is done by T1. Correct? And who is doing final write for A in S2? Final write on A is S2 or in S2 is also done by T1. You watch this. After this, there is no write A. Okay. Let's confirm who is doing final write on data item B in S. In S, final write on data item B is getting done by T1. Okay. Final write on B. And what about final write in S2 on B? In this schedule S2, final write is getting done by T1. Fantastic. That means initial read and final write on both data items is satisfied. Okay. Now, one more last condition remaining. What was that? Updated read, isn't it? Updated read. So in these two schedules, S and S2, we have to see updated read. Tell me what is updated read? Except for initial reads, you see, are there any remaining read operations? Except for initial reads. I'll just clean up a few things. So except for initial reads, I was saying, you check, are there any extra reads? Look, this is initial read on A. Is there any read A after this? No. So no question about it. Look, this is initial read on B, isn't it? Initial read on B. Is there any other read on B? Yes, here is the read. So leave aside the initial read of B, but the successive read of B, not the initial read, has to be checked. And you can see that T1, this is transaction T1, is reading B, reads B, correct? Who has updated that B before in T2? No one has updated this B. There is no write B operation. So this is not an updated read. So question ends. I hope you are understanding. And after this, there are no reads. So there is no updated read, I can say. There is no updated read. So updated read condition need not be checked. I hope you have understood about this read B, correct? Because this read B operation, is this reading the B which was written by the other transaction T2? No, T2 did not write anywhere before this the value of B. So there is no updated read either. That means S and S1 are view equivalent. Hence, S is view serializable because it is equivalent to one of the serial schedules. Thank you very much.